All right, so this week in class we did a lot of modeling. We drew out the cycles of water. How does water move through the earth, through the atmosphere, through the biosphere and geosphere, hydrosphere? How does carbon do the same thing? Okay, so it's really important to understand each of the individual processes in both of these cycles, but also how they connect to one another. Okay, when a water molecule moves from a lake to the atmosphere, what is that process called? When it goes from the atmosphere back into the soil, what is that called? So let's just do an example of this. You should be able to do this on your own, hopefully without your notes by the time you take the formative. If you can do this for the carbon, water, and nitrogen cycle, you'll be in really good shape for the formative. Okay. So let's start with a lake. This is a body of water. It is full of water molecules that are in liquid phase. Okay, when it is heated up by the sun, right? Here's our sun. These form water vapor. Okay, the water goes from liquid to vapor, to a gas, in the atmosphere. Okay, these water vapor molecules may not be visible to you unless they're kind of close together and form condensation. But this first process, let's see if we can do this. This is called evaporation. Okay. Now, when those water vapor molecules move closer together, they're going to become visible. They're going to become a little closer together. They're going to become bigger droplets, right? So this is called condensation. And when they come together like that, you might see them appear in the atmosphere as corn sweat or as clouds or a cloud forest. Okay, so this process, when those water molecules cool down a little bit, is called condensation. We also see this on our Pepsi cans on a hot day because the cold surface of the can is collecting water vapor molecules in the air and bringing them together into little droplets. Okay. All right, now let's add some land here, and let's add another cloud because why not? Add land next to our lake. When those water molecules in the cloud, right, they're pretty close together. When they get even colder and closer together, these will form water droplets that are big enough to not be floating in the sky anymore. Okay, so this is a raindrop. This could also be a snowflake if it's cold enough outside. It could be wintry mix. Midwestern weather gets really creative with our precipitation, and that's what this cycle, or this is what this process is. So let's draw this out here. Okay. So precipitation is when the water vapor molecules get big enough, or they condense enough such that they fall out of the sky. Okay. When they hit the ground, they have several different things that might happen. If the ground is compacted, let's say it hits the Walmart parking lot, it's paved over, there's not a great drainage system, there's no roots in the cement, the water is going to run off the surface and into the lake. This is ever so creatively titled surface runoff. Okay. We don't love surface runoff. It seems like a waste to be not using that water. What we prefer is if these water molecules, these precipitation, these raindrops and everything, move into the soil. If the soil has enough air channels and spaces between it, if it's a healthy soil, what can happen to that precipitation is called infiltration. It kind of sounds like filter, like a coffee filter moving through the earth. Now, if if infiltration happens and water is allowed into the soil, then this can be taken up by a nearby plant and its root systems, right? There we go. Make a little daisy here. Oh. We'll make some leaves too, because that's where the water vapor comes out. I'm going to make a different color here because I want to show the water moving through the roots, through the plants, and out back into the atmosphere as water vapor, right? This is called transpiration. Okay, you need a tree, you need a plant for transpiration to happen. It's kind of like evaporation through a plant. Plants contribute a lot of water vapor to our atmosphere through the process of transpiration. Okay, so let's see. We've got transpiration, infiltration, 3, 4, 5, 6. There should be 8, right? Okay, now let's look over here. Actually, we can, I wish I didn't put my plant here. Transpiration and photosynthesis are very closely linked, okay? And what I mean by this, I'm going to put photosynthesis in here because the doors, oh, I couldn't move that over. The doors that allow for photosynthesis to happen are called the stomata, okay? Those are in the leaves of the plants. When they are open, carbon dioxide can come in and photosynthesis can happen. Those are the same doors that allow for the water vapor to escape from the leaves. Okay, so transpiration, when transpiration is happening, photosynthesis is also able to happen. When photosynthesis is shut off because the stomata, those doors are closed, maybe the plant is trying to retain water because it doesn't want to dry out, then photosynthesis has to stop as well. Okay, they can't take in carbon dioxide if the door is closed because they can't. Okay, we'll learn about that more in outcome 5, I think. Okay, so these two are very closely linked. The last one, excuse me. Let's draw a human. Oh, I didn't realize that was still blue, but that's fine. We've got a person, okay. Cellular respiration is part of the water cycle because we have to drink water, right? All living organisms need water, so water goes in, but when we exhale carbon dioxide, as you'll learn in the carbon cycle, and we also exhale water vapor, okay? If you breathe onto a glass, right, onto a window pane or your glasses or something, you'll be able to see water vapor molecules come out, and that is part of cellular respiration. Okay, here. Oh, boy, it likes to do that today. I've got a one-eyed person. I want to change that. So, water goes into the person, and water vapor escapes through cellular respiration. So let's put that last cycle in here. Did not want to move it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 processes of the water cycle, and that is how all of these things are linked. Okay, so we have water vapor in the atmosphere, we have water in the ground, we have water in the hydrosphere, like lakes and rivers. We have water in the biosphere, anything that's living, like plants and humans, animals, fungi, they all require water. And so those living organisms are one reservoir or one kind of sink or source of water in the atmosphere, or water in the world. Okay. Hopefully that was helpful. See if you can draw one out yourself.